This is Dr. Holt. This problem is number 8. I want to go over this one. This one, you have an initial kinetic energy imparted to a 0.25 kilogram bullet is 2211 joules. Here we want to neglect air resistance. We're going to find the range of this projectile when it's fired at an angle such that the range equals the maximum height obtained, and they use the acceleration of gravity is 9.81 instead of 9.8. First thing you want to do is take your kinetic energy, you set it equal to 2211 joules. You set that equal to 1/2 mv squared. So now we have 2211 is equal to 1/2. We have the mass of the bullet, which is 0.25, and we got velocity squared. So now we want to solve for v. Grab the calculator, see what we get there. We do 2211 times 2, divide 0.25, take the square root of that. That gives us 133, basically 133. So V is equal to 133 meters per second. So now it says the range is going to be the same as the maximum height. I'll just draw a quick little picture here to help. Okay, so here, vector coming up here, a vector coming to say down here. A couple of things we know from previous sections is this is theta, that'll be theta down here too. This angle will be the same. Object's going to go up like this, reach maximum height, come down. So we'll call this distance to be x, and we'll call this distance here to be x. Those have got to be the same. Okay, so now we go back. We'll do the vertical first. We know when we're finding maximum height, we go back to the equation that VFY squared final is equal to VIY squared plus 2 times negative, and we'll use negative 9.81 times delta y. I want to solve for delta y, which is also going to be equal to x. Now here our VF will be 0. Our VI initial is going to be 133 times the sine of theta. We'll square that. We'll solve for, just go ahead and write it all out. Plus 2 times negative 9.81 times delta y. Solve for delta y. Move this to the other side. Obviously the negatives are going to cancel out. That'll give me 133 sine of theta. We'll just square that one, all over 2 times 9.81 is going to equal to delta y. Okay, then we'll go back and we'll solve it in the x direction. We know, oops, this is from previous work. Let me go ahead and eliminate this, and I'll rewrite this here. We know when we do our x components that we have no acceleration in the x direction, so that we know that delta x is going to be nothing more than Vx times t. So we'll go ahead and write that out as delta x, which is also equal to delta y, because our x directions are going to be the same. So we'll put in 133 squared times the sine of theta squared over 2 times 9.81 is going to equal to our Vx, which will be 133 times the cosine of theta times time. Now time is going to be based upon how long it takes it to go all the way up and come all the way back down. We can get that by going back to, again, to our kinematic equation, that we know that Vf is equal to Vi minus 9.81 times t. We know when this object, if it goes up if its initial velocity is 133 times the sine of theta, going up, this has to be 133 times sine of theta negative coming down. So we just put those values in, minus 133 sine of theta is equal to 133 sine of theta minus 9.81 times t. Move this over and divide by negative 9.8. That's going to give me 266 times the sine of theta over 9.81 is equal to t. So we're going to substitute that back in. It gives 133 squared sine theta squared over 2 9.81 is equal to 133 cosine theta times 266 times the sine of theta over 9.81. Alright, so now what we want to do is try to simplify as much as we can. We can eliminate this one and eliminate this one here. We have 133 here. We can eliminate this, eliminate this. We got 9.81 here, 9.81 here. So now I'm going to go ahead and solve for the angle first. And I'll get it into a tangent. I'm going to divide both sides by cosine. I'll do this in steps so I don't lose anybody. Divide by cosine, that's going to give me the tangent of theta over 2 is equal to 266 here. Move everything the other side. That's going to give me the tangent of theta is going to equal to 2 times 266 over 133, which basically is going to give me the tangent of theta is equal to 4, it looks like to me. So we solve for theta by taking the inverse tangent. Go back to our calculator. Second tan of 4 gives me 75.963. 964 actually. Alright, so now we want to find maximum range. We can just start plugging everything back in. We'll go back to this equation right here. This is going to give me our maximum range. So I'll take 133 cosine 75.964. Now we need to get our t value. We'll solve t based upon this. So t is going to equal to 266 times the sine 75.964 over 9.81. Run that value. And give me 26.3. So the time is in the air quite a while. 3056. We'll put that in right here. And again, all I'm doing is VIX times T. So now we'll run that value times the cosine of 75.964 times 133. And that gave me a value of my range, or my x value, is going to equal to 848.531 meters, or 0.84853 kilometers. Alright, that's how you work that problem. Again, that problem's not very difficult at all. It's just you basically got to set the change in y equal to the range. You got to get time in terms of the angle also. Alright, hope that helped you. Best of luck with this problem.